Alright, so this is the part 2 of our assignment. So we're skipping down to number 49 through 55. We're going to find the zeros of the function algebraically or graphically, and honestly, anytime it says graphically, I go ahead and do that. So, we're going to type this equation into our y equals and see what we come up with. So, typing into the y equals, generally I will also do a zoom standard. So, number 6, apparently the cat wants to leave the room. Okay. Alright, and so if you graph on a 10 by 10 grid, you don't really get a whole lot to work with, or at least if you just look at it without thinking of what it's doing. But it does go up, and then of course for a very long time, and then goes through for a very long time, and then back up again. So, all we're really looking for, of course, is the zeros, or the x-intercepts. So we just need to find this point, and this point. And of course it does kind of continue in that direction. So, one way of doing it, of course, is to trace and realize that that's probably, well, officially this one's at 0, 0, because it just kind of automatically goes to that. But it looks like 1, 2, 3, 4, 5, negative 6 might be the other 0. So I just type in, after pressing trace, that negative 6, 0 is this point here. And then 1, 2, 3, 4, it looks like 6. Yep, and so 6, 0 is our other 0. So that means that our coordinates are negative 6, 0, 0, 0, and 6, 0. Alright, the next one we're going to graph as well, and so we're going to type in x cubed, which we already have, and the rest of it. And again, once you're done graphing all of that together, we have something that is not very easy to look at, but basically it goes up, it looks like, and then down, which of course seems weird with a trinomial, but it may go back up again. So now I want to be able to figure out what those zeros are. So algebraically you could factor by grouping. That is an option here. Let's see, 55 and a 7. I don't think 55 can be divided by 7, so it doesn't look like it's going to be a whole number. So instead I'm going to just expand my window a little bit. And so, since I'm looking for zeros, I can go ahead and stretch my x-axis. So I think I'll just go negative 20 to 20 and just kind of see how that works. Aha! And so it looks like it does come back up here. And so we just have one that was outside of that 10 range. So again, if you press trace, you can go back and find out, let's see, 1, 2, 3, 4, 5, is it 6? Negative 6? Ooh, definitely not negative 6, negative 5. Okay, so negative 5 is one of ours. Then over here, it looks like it might be at 1. Yep, so 1, 0. And then a little bit past 10, so it looks like 11 for this other intercept, or 0. So that means that our zeros are going to be negative 5, 0, 1, 0, and 11, 0. And again, that was all through trace, but you could also go to second and then trace, and then that would go up to calc, which means that you'd calculate zeros by going left and right of where you think it is. You'd also go into the table. Wow, lots of options. Alright, so in number 53 through 56, the odds, we're using only algebra to find the cubic function with the given zeros and support by graphing. Okay, so we did one of these in notes and we kind of expanded it and we didn't really need to. So if we take a look at the cubic function that's going to do this, if these are all the zeros, our factors are opposites. So negative 3 for a 3. Positive 4 for that negative 4, and then negative 6 for that positive 6. So this is the trinomial. Literally, you don't have to do anything else with it. You could expand it, but we really don't need to, because this is still a trinomial, a cubic. It just doesn't look like it has a power of 3, because it only has 3 powers of 1, which of course would multiply to be a power of 3. So you can support by graphing. And so if you type this equation into your y equals, and then go back to a standard grid, because we can fit all of these zeros in a negative 10 to 10. And so going back quickly to a negative 10 to 10, you can click zoom and then press number 6. And so you can see that you will have all those zeros. So negative 4, 3, and 6 are all pictured in there. The next one's not as fun. So in that case, it's the same idea though. If you have a negative, even if it happens to be an irrational number, the factor that comes with a positive square root of 3 is going to be a minus square root of 3. That's supposed to be a 3. The next piece is going to come from x plus the square root of 3 for this next one. And then the last term is going to be x minus 4. And so that again is our function, and again you can graph that with a calculator to support it, but pretty sure we're just going to have our intercepts at each of those initial numbers and then we're good. So that looks like it's the end of the assignment. Alright, so again that was part 2 just to finish it off.